I'm actually going to make that point about why it makes financial sense to use cloud management. And I'm going to start with a little bit of historical background. I actually used to work for a telco. Before the internet, telephone companies would sell frame relay networks to corporations that needed point-to-point connections between their offices, sometimes called fast packet. And we would actually draw a diagram like this for somebody that had offices in, say, New York, Chicago, LA, San Francisco, and we would paint the cloud, because the cloud, it's really a metaphor for complexity that did not need to be explained. If you were this company buying a 4-point network, you don't need to know what points the data travels to get between your New York and your San Francisco office, which is a lot of equipment. You just need to know the connections that it was traveling. And if you want to be more on the pedantic side, this dotted line here really should be inside the cloud so that you can see it. So it's shielding complexity we need to worry about. These blue symbols are what Cisco uses for routers. That's where it says router 1, 2, 3, and 4. And it also serves to show a point of demarcation. My equipment is outside of the cloud. The stuff inside the cloud is what my provider is managing for me. This term goes actually decades back, 50 years to the 60s, as you can see that I'm referencing here. And if you think of cloud computing as, now not cloud, but cloud computing, as we think about it today, it's extending the demarcation line to also include the servers that your applications are running on. That's really the historical context for that. And my friend James Urquhart from Cisco, and he writes a blog, I like the way he explains it, an application-centric operations model. I'm managing my applications, not the equipment and the IT infrastructure and the servers that it runs under. Now, there's already been a lot of explanations of infrastructure as a service and platform as a service and software as a service, so I'm not going to go into that again. But I do want to draw one distinction and add a couple of notes. Notice I got an X and a Y axis, increasing automation, increasing portability. It's really hard to take something that, say, runs in Google App Engine or Salesforce's Force.com and move it anywhere else, because it's custom tailored for that particular platform as a service. You get tremendous benefits of not having to manage, again, that complexity underneath what servers, what operating systems or configurations, but you're locked into that particular, or at least more difficult to move into the particular structure you develop. On infrastructure as a service, it's just servers the way you know them today. The bridge that we cross with RightScale, and why I have it here, is that we deliver a lot of the benefits of platform as a service without keeping you from being able to make changes to configurations and modifications to servers. RightScale has a lot of pre-configured assets for databases, application servers, load balancers, you name it. Lots of those building blocks that you also get in a platform as a service, where you can more or less drop in your code. But on the RightScale infrastructure as a service example, you have root access to all your machines, so you can pop the hood, tweak, configure, modify anything. So it's a really interesting balance we've been able to deliver of tremendous flexibility, as much as if you had a server in your own office, with also a high degree of automation. Now, in the abstract, we talked about describing the technological landscape that we see for cloud computing. So I wanted to share something with you that we developed internally, and we decided to actually share it with the rest of the world. So this is kind of an overview of where is this industry right now. And once again, notice the X and the Y axis. So infrastructure, middleware going up to applications, and then left to right, in-house to public cloud. So this oval here, and I think I have a little bit of animation to go, we're looking really at your classic data center kind of technology. So things you're managing with HP OpenView or CA, Unicenter, or IBM's Tivoli, all the regular data center stuff that we have today. That's been existing for quite a while. That's really been evolving into private cloud technologies. So companies, for example, that are outside right here, Cloud.com and Eucalyptus and some others, that deliver technology that allows you to create your own private cloud. It could be just for your own enterprise, or you might be creating it as part of a service provider, which is what I have on the third oval. And notice things overlap, by the way. There's no clear black and white boundaries. on a lot of this stuff, because you can be building an own internal data center powered by cloud.com, or you can very well be a service provider that's doing that. And I will show you examples of that. So that's kind of the range that we see here at the basic tier. On the public cloud technology, we have enabling technologies like ZenCloud platform and VMware's vCloud that, again, some of these public clouds are using. And then some of those have their own management consoles that they deploy. So Amazon has the AWS console, Rackspace has Kickstart that they purchased and they integrated. So you have a simple graphical user interface to be able to deploy into those. That's kind of what we're seeing in the ecosystem here. A really interesting development is this idea of server configuration management. You might have heard of things like Puppet and Chef. These are open source technologies that companies are now leveraging to be able to contextualize servers as they boot up. So instead of a server being pre-configured, the servers actually look for their role as they stand up in a virtual environment and are given instructions of what they're going to be. Are you going to be a database, an application server, a load balancer, and you can pass it all sorts of configuration parameters. So this kind of exists on a layer above that. And as you move a little bit beyond that, draw a reference to the diagram I was just showing before. Infrastructure as a service cloud management platforms. This is where we fit. We're not the only company in this particular space, but we do have a very unique take that I'll explain a little bit more as we proceed. And platform as a service, I use the example of Google App Engine and Force.com. Think of those as code execution environments. Upload my business logic, my application itself, and it runs there. And at the simplest, things like Salesforce.com, Google Apps, there's not a lot to manage. All of that supporting whatever your strategy is going to be for deploying to the cloud. Again, something we prepared internally to try to analyze how do we see the world as it comes to cloud business and the ecosystem that we're sharing now. So we already seen some major successes from companies that have been innovative, perhaps before you could have called them risk takers, and really adopted the cloud. Let me take an example that's actually quite fun because of the massive scale. Zynga, and just look at the numbers. They have 250 million monthly active users. That's almost the size of the whole country for the US. And on Farmville has 25 million people playing it every single day. In fact, when Farmville launched, 1 million people signed up the first week, another million the second week, another million the third week, every week for months. I think it was in 5 months, 25 million people playing. So more than 1 million people signing up every week. And let me be clear here. I don't mean people signed up and left their email address. People signed up and became daily active users. More than 1 million new ones adding every single week. So we've already seen some rather massive deployments in the cloud that have been very successful. And well, how do they do it? There was a slide from earlier this morning where our CEO was talking about it, and he said, using cloud is not the same as designing for the cloud. What happens a lot today is people take exactly what they were doing and they want to boot up the same server and perhaps run it the same way in the cloud. But in the cloud, you really have a different paradigm, and maybe that word gets overused, but you literally have access to disposable hardware and all these resources at your fingertips, yet many people decide to just build things the old way as opposed to taking advantage of a cloud management platform, such as what RightScale has been doing with Zynga, for example, to highly automate the processes that you run in the cloud. So I was showing some really large numbers. Think about what it would take to deploy that without access to cloud services, but also without automating those infrastructures as they scale. Even for a company like Zynga that can write a check for millions of dollars, maybe tens of millions of dollars, could you procure those many servers, install the operating systems, configure the applications, manage all that growth? So it's really an amalgamation of those resources from infrastructure as a service and the automation that you can get from a cloud management system to be able to create environments that will adapt and can scale or shrink based on load. Do they need the same number of servers running at 2 in the morning when not as many people are growing them? So what they undertook was really an analysis in conjunction with us in an advisory capacity. What is the best way that we can take advantage of the assets in the cloud? And let me use an analogy here, because for those of us that have been working on IT for a long time, it's just natural to get stuck in the way that you see the world and how you think about what your particular business is. So, for example, in the late 1800s, the Lumiere brothers invented the film camera. The entertainment of the day was movies. So what do? They took a film camera to a theater, and they gave the camera what would have been the best seat in the house, right in the center, and they recorded plays. That was the paradigm for entertainment. It took years. It took years until somebody figured out you can put the camera on the stage and record a play from a better vantage point. And it took decades until somebody realized you can move the camera while you're recording a movie, what they call a tracking shot now. I live in Los Angeles. I submit to you, we're seeing some of the same things with cloud computing. You have access to all this new technology, yet you're building the same old thing. That's why I was using the example of Zynga. I realized not everybody's looking at 25 million daily active users for their application. This works well when you're looking at dozens of servers as well, but I'm talking about taking advantage of the resources by automating the way that you control them. That's really the point that we want to make, and that's why I'm showing that funny graphic there. I want to make another interesting point talking about Zynga. Everything that I'm discussing are things that they said publicly. They've been very vocal, especially lately at the NetWorld Interrupt trade show in Las Vegas. So by no means am I discussing anything that's just been private between companies. I'm just repeating things they're saying about themselves, and I'm helping them spread their own message. We're always very careful to maintain that confidentiality with customers. And there's another interesting thing that's happening here in terms of their path. They first had their own data center. They realized the benefit of deploying to a cloud, and this is years ago now, so Amazon was their choice because these games can blow up in a massive, massive scale, and even if you can afford it, it's rather challenging to build that. Once they were doing that for years, they realized that for some games, that tremendous variability of the usage would cease to be as extreme because the players sort of even out. And they looked at building their own private internal data center, what I'm calling here a hybrid cloud. So it's interesting how they've gone full circle. To plug in again this idea of cloud management, using RightScale, they have one single pane of glass, a phrase used earlier today, to control all those servers. It doesn't mean they have an environment in Amazon and another one in their own data center, separate teams, separate infrastructure, separate designs, separate configurations. It's one set of configurations and architectures. In fact, they can deploy a game in Amazon, leave it there for months, and then move it to their own private cloud, the exact same configuration once it evens out. I submit to you, you want to be at a particular scale to make that work, but technology, to make the capital outlay of a private data center work. But in terms of the technology and the software, that's something that is working rather well. Let me make one more point here in terms of what I was talking about, the best uses. In a data center world, let's take the example of databases. People usually put their database in a really expensive machine, multiple drives, multiple power supplies, fans, to keep it from failing. And they go further, they have a couple of servers, master-slave in case somebody dies, in case your primary database dies, because it's such a core part of your environment. When you're looking at a cloud world where you have access to disposable hardware, a new set of best practices have been developing. If your master database fails in the cloud, you could call a DBA and spend some time fixing it, or you can promote your slave to master. If you've been replicating properly, you have all your data, promote your slave to master so your app server is going to talk to that machine, stand up a brand new server from a known good configuration, make sure the replication starts again, and you're back to your usual setup. So look at how much time and effort you just saved, both in downtime and in human cost of getting things going. This is what I'm talking about when I talk about cloud management and having this new approach. But we were going to discuss also what's still hard, what's difficult. And that's the multi-cloud part. And this is one of the areas where we've invested very, very heavily and where we drive to add value. When I talk about multi-cloud, I mean that people want to have the ability to have different providers, but also different companies are emerging that provide different capabilities. Not every cloud provider is going to have the same, not just pricing, but also set of features. So you can find yourself building something and then you decide that that's not exactly the architecture you were going for. So now I'm going to use an example from a different company, Netflix, that also happens to be rather open about how they're using Amazon extensively. And it's been great to get all this useful information shared from them. And this is the benefits of the cloud that we all know, but this is being said by a company that's putting millions of dollars behind what they're saying. So it's not just bloviating by somebody, because they had tremendous demands driven by growth. Very successful marketing campaigns. They need to keep up with adding lots and lots of more users. How do we keep up? So they looked at it in a logical way. What business are we in? Are we in the business of building data centers and investing lots of capital in there? Or should we just be putting all that effort into deploying our own applications that we're building? I tell you one thing that it's important to nevertheless consider. I used that example before of the cloud being a point of demarcation between what you manage and what you don't. So as you start building an environment that, say, works really well in Amazon, now you're also building for yourself a way to control and manage that system. So it brings back the question of what business are you in? If you're deploying a system in Amazon, you got to look at things like how you're going to manage lots of different users having access to those computers. Does everybody get the same username and password and have access to all the different machines at the deep level? So what do you do about having a user permissioning system that works in a cloud or across multiple clouds? What about having some configuration management so that you know what you're deploying so you can repeat those? Or being able to track cost. I don't know if you noticed in the demo this morning when Daryl and Michael were speaking, we're showing how for different deployments, groups of servers, you can actually see how much each one is costing. So you can keep an eye on that. So if you're a company that's just building an environment and creating all these tools for yourselves, you're now veering into a different business than building your own core applications. This is the part where we add value. There's an interesting challenge that happens here on the last bullet. We keep hearing this anecdotally. It's so easy to open accounts on EC2 that lots of companies do it, but also lots of employees independently do it within a company. So we hear from IT managers that say, look, I just realized we have 12 different people, each with their own EC2 accounts. How do I manage, how do I control all that? So it brings an interesting set of challenges there that you need to look at. That's the angle that we come at from this thing. After all, when you're looking at a lot of the infrastructure as a service providers, it's building blocks. You still need to build environments out of it. It's very useful that you can provision them so easily, but you still need to make a useful application out of them. Where do you want to spend your time and effort? Creating a cloud management system so you can control your servers that are running in one or multiple infrastructure service providers, or redirect that effort to what's core value to your own company. That's my thesis here. Now, there's the multi-cloud angle, and I love this. I love this photo that I found, by the way. We have the following. Yeah, we have the following view of the world. There's very clear leaders today, but we're fast seeing a world with lots of companies entering the market for infrastructure as a service. Once upon a time, quite a few years ago, there was this broad thinking that Linux would consolidate into the best version of Linux, that most companies would gravitate to whatever was the best one, and that vision that was widely expressed at this time never came to be. It turns out that different companies followed different strategies. One Linux vendor was focusing on having it be more secure, another one on it being faster for high performance application, a different one with a separate commercial strategy for licensing, or it could be for embedding, or it could be for selling into the enterprises. We are already seeing, and we've been expecting this for a while, to be a proliferation of clouds with different approaches to their technology, but also different APIs and different services available within them. So how do you address all those different options that are presented to companies, and how do you have the possibility of starting with one environment that you then have a different project with different requirements that might best run in a different location, in a different provider? That's where we invest a lot of time and effort, and we have a deep engineering team for that. These three logos that you see here are partners that we have that provide technology that allows you to build an infrastructure as a service cloud. And just to give you a sense of how active the marketplace is, this is a slide from cloud.com. Just cloud.com has a bunch of different provider clouds, each one with potentially a slightly different API and slightly different services. And then if you broaden the circle, just from cloud.com Power Technologies, these are meaningful, real infrastructure as a service companies that we are looking at right now that are in the business, all with different mix and matches of features, prices, benefits, distribution models. Let me now use a different analogy here. When somebody's, well, actually, notice how in my diagram I have the infrastructure service providers and the applications you want to run, and we're this layer. In this case, think of RightScale as an abstraction layer between the applications you want to run and the clouds you want to run them in. Drawing the analogy from operating systems. When you're running a program, you don't actually talk directly to the hard drive or to the network interface card. You are running your application logic, communicating with the operating system that has the correct drivers to communicate with different components. That means that if you run a program that runs on an Intel motherboard, you don't need to know exactly the chipset, and your program will run on a different computer, maybe not even an Intel chip, and different chips, Intel CPU, and different chipset altogether. When we say cloud management platform, not only are we talking about all the automation that I've been describing that makes it possible to manage large or medium or even smaller environments with fewer people and getting all those advantages, but also having this abstraction layer so you don't write an application that's so deeply woven into one particular provider that it's impossible to migrate somewhere else without rewriting it in a drastic way. And let me explain how we approach that. Central to RightScale is this idea of server templates. And let me contrast them to an image, a virtual machine. That would be like a CD. You can make as many copies as you want, but you cannot change anything on that image. So it's rather useful, by the way. I can clone it as many times as I want. I stand up a virtual server based on that image. I log in, I start making configuration changes. Maybe I burn it again into a new machine, but all I can do is make copies. A server template, a core technology, everything in RightScale runs around server templates. It's more like a playlist. I can make copies of it, but I can also change the order of the songs. I can add songs. I can delete songs. That gives it a tremendous amount of flexibility. Different diagram to show the same idea. In a server template, you have a virtual machine as well with an OS, but what we do is we put just enough OS for that machine to boot. Just CentOS or just Ubuntu, just Red Hat. And as soon as that virtual server becomes available, we start running a series of boot scripts that will install and configure things. So if it's going to be a database, it's installing MySQL. If it's going to be an application server, it might be installing PHP. If it's going to be a load balancer, it's installing HA proxy. But not only does it do that, you can then do a lot of other configuration things. If it's going to be an application service, I just said, another boot script could be connect to the database. Now, you don't even need to hard code the database. You can pass values to that script so that you can say, connect to the database and leave that field blank. So you need to provide that information to the server before you stand it up. That's how the servers can contextualize themselves as they become available. Another script can be application server, find the load balancer, let them know you're available so you can start passing your traffic. So it's this whole idea of dynamic configurations as opposed to static configurations that all you can do is clone. That means we're abstracting out the business logic of what your server does from the operating system that tells it how to communicate to the cloud provider. So another very useful result of that is you can take the server template for the aforementioned application server and change the virtual machine from one that runs in Rackspace to one that runs, say, in the Tata cloud that's a different provider altogether without modifying the business logic of your application server. That's how we approach the idea of portability that I was discussing earlier. Is the idea of separating the logic of how your application works to the exact way that it communicates to that cloud, therefore making it possible and a lot easier to deploy to multiple providers. And it could be, by the way, so you have a warm DR site with a different company, you're running everything in your preferred provider, you keep a database running in a skeleton architecture just in case you need to shift traffic. For DR purposes, it could be to be geographically more close to where your customer base is. Maybe your provider of choice for North America doesn't have a data center in a location in South America, for one, and you need to be closer to the customer base. It could be so you can run some things in a public cloud and some things in a private cloud, as I was explaining before. There's lots of really interesting use cases where you have the flexibility to move those workloads to wherever it might be more appropriate today or in the future. It's not just about planning, how do we get this going as quickly as possible, it's what happens later on. Which brings me to the why cloud management makes financial sense question. There's all the work that you could do to reinvent the wheel and recreate a lot of the things that we have built to automate these processes. And we heard in that one of the speakers earlier today, I forgot the name of the last speaker, the guy from a Trader Media. He said he was able to deploy an application 4 weeks faster, and make an additional $1 million of revenue because of the automation that his company uses with Amazon and with RightScale in this particular case. That's what you're seeing on this graph here. So speed to market. And in the case that we saw earlier today, he was actually able to quantify it, in fact. You have cases, for example, the guys that invented the RISC computer chip, they all work for a different designer. They left the company in San Francisco, very much a startup kind of environment. They say, we're going to start our own chip design firm. The first thing they did, they bought a bunch of motherboards, power supplies, and chips, and they spent a week and a half building PCs because they thought that was cheaper. When they finished, they just realized, what did we just do for 2 weeks? What business are we in? We could have just bought some Dell computers, put them on our desk, start designing chips as what we're planning on doing, or we spend doing something else completely separate. That's what we're showing here, saving time and effort on those initial deployments and the initial work. And then on the ongoing maintenance, having this extreme degree of automation. I was talking earlier, you got a master-slave database and your master database fails, being able to automate the process of promoting that slave to master, setting up a new machine. There's a gazillion operational things that come in really handy like that literally save the bulk of the time and effort that IT personnel spend today putting out fires. I was talking to the CTO of a different company, I don't know if I can repeat his name, and he told me, I'm running anywhere from 100 to 350 servers, given the time of day and how many people are using my link sharing site. I have a part-time helper that helps me manage the whole environment. 350 servers. Think of what that takes in a non-cloud world with not a cloud management system. You're talking about a team of dozen or dozens. I used to work in a data center. But the most interesting thing is I'm not chasing, I'm not running around putting out fires. I'm spending my time developing new features for my company.